right, hopefully you've built your little foldable with the properties of a rhombus. Now we'll look at a few of the problems we're going to deal with for rhombus. Let's see. RSTV is a rhombus, and it tells us the measure of angle SWT equals 2x plus 8. So let's see where that angle is. Let's highlight it in red here. Okay, so we go from S to W to T. It's talking about this angle right here. And we can see from property number 7, you look at your picture, what's true about that angle? That is, these diagonals are perpendicular, so that's a right angle right there. Okay, so we know that's 90. So 2x, our equation is 2x plus 8, the measure of this angle, equals 90 degrees. And so we go ahead and solve that. We'll subtract 8 from both sides, get x by itself, so we get 2x equals 82, divide by 2, and x equals 41. So just using your properties, you know, you can go look, first you measure or take a look at the angle they're talking about. Okay, let's see, we had a picture in there somewhere. Yeah, that angle is 90 degrees because these diagonals are perpendicular. So use your notes, you'll be able to use them on test and quiz and to do your practice problems. Next we've got a problem. It says, what is the value of y if the measure of angle WRV equals 5y plus 5 and WRS equals 7y minus 19. So let's mark these angles and see where they are. So the first one is WRV. So we start at W, go to R, and go to V. That's this angle in the corner here. Then we go from WR to S. W to R to S is this angle right here. So property number 8 remind you of the diagonals bisect opposite angles. So we saw that picture. These two pieces are equal because this diagonal is cutting it in two equal pieces. Bisect, cut it in halves. Okay. So we set 5y plus 5 equal to 7y minus 19. These angles they gave us are equal. So I'm going to subtract 5y from both sides, and that gives us 5 equals 2y minus 19. Then we'll go ahead and get rid of that minus 19 with plus 19, get that y turned by itself. We get 24 equals 2y. Divide by 2, and y equals 12. Okay, you can pause whenever I go too fast. But again, they gave us two angles right here, and we knew that diagonal cuts them into equal pieces, so these are equal angles. Gives us our equation. This one I put in the information into the rhombus. DM equals 24, so DM is that whole diagonal right there is 24. Whoops, moved a little bit. What else do we have? Angle LDO. So we go from L to D to O. In this corner right here is 43 degrees. And then DL up on top, this side on top is 13. So now let's go to answer the questions. OM. From O to M is that half of that diagonal. So we just cut this in half. 24 divided by 2. The whole diagonal, 12. Angle DOL. DOL is this angle right here, and we know that these diagonals are perpendicular. This angle is a right angle right here, 90 degrees. Then we have angle DLO. So we go from D to L to O. That's that angle right here in this corner. Well, we don't know any of the other little ones, but we know two of the angles in this triangle, so we know all three of them have to add up to 180. So what we do is take 180 minus the 90 minus the 43 gives us 47 left. That angle is 47. Those will add up to 90. And what else we got? Angle DML. So we go from D to M to L. That is this little angle in this corner right here, not the whole angle. Well, we know these bisect these, opposite angles are equal, then it cuts it in half. All these little halves on this diagonal are equal, so it's the same as this 43 over here. And then the last one, segment DP. DP is over here. Well, it's the same. All these sides are the same. This one's 13, so they're all 13 in a rhombus. Alrighty, so there's that. Let's take a look at the next part. We're going to be talking about a square. So here's the description of a square and kind of the definition, one definition. A square is also a parallelogram. So all those properties about parallelograms are true about a square. And some new ones. It's a parallelogram with 4 congruent sides. So similar to rhombus, it has 4 congruent sides, but what makes it different is, and 4 right angles. All the corner angles are right angles, 90 degrees. So there's a little picture of that. So next we go with listing the properties again. Okay? So we're going to make a foldable for this one. Now I didn't do the first 5 because they're the same. First 5 in a parallelogram and in a rhombus and in a square because they're about, being a parallelogram. Okay, so you're going to mainly do these last 6 here. These last 4, 6, 7, 8, 9, and 10, these last 5. So we'll look at 6. Number 6 says, along with its description, it has 4 right angles. So in your foldable, you're going to write number 6. A square has 4 right angles, and draw your little picture of it. Number 7, the diagonals are what? Let's see. Congruent. So in this picture, the whole diagonals are congruent. That means, from A to C is the same distance as B to D. Now, they still bisect each other, so something you can add to this picture is, since they bisect these pieces, not only do these pieces equal each other, but they're all the same. If you knew this little piece right here, well, this one would be the same, this one would be the same, this one would be the same. All congruent. Next, property number 8. It has 4 congruent sides. Again, that's part of the definition of a square. So all these sides have little congruent marks. Sorry, those are left in there. Let's get rid of that. Alrighty. So all 4 sides are congruent. Number 9, similar to a rhombus, these diagonals are perpendicular to each other, just like in a rhombus. So they make the 90-degree angles here on the inside. All 4 of these angles where these two meet are 90 degrees. And also similar to a rhombus, number 10, the diagonals bisect opposite angles. So you can add this to the picture too. All these corner angles are 90 degrees, so if it bisects it, if it cuts it in half, we know exactly how much they are. They're 45 degrees. And since they are all 90 in the corners, well, they all get cut in half, and they're all little 45s right here. So we can see we have basically 45, 45, 90 degrees, because this is a 90 right here in the middle, at the top of the triangle also. So let's take a peek. Let's call this part 2. You're going to go ahead and finish up your foldable for a square, properties of square, and then we'll look at some examples.